Today we're going to talk about hypothesis testing using the mean. So step one is you're going to hypothesize. You're going to state your hypothesis about the population and the parameter. And as a reminder, right, when we do stuff like that, it's we use this kind of language, right? H naught and HA, right? So H naught, and before we were using P, but now what we're going to do is we're going to use our little, and this stands for our, right, for our sample. Oh, no, sorry, for our mean, right? So we're going to say the mean, we hypothesize that the mean is equal to something else. And here we can either, remember with our alternative hypothesis, it could be anything that does not have an equal sign. And with our null hypothesis, we have the equal signs, right? Um, so step one is you have to have a hypothesis, all right? Step two is prepare, get ready to test. Choose and state a significance level, choose a test statistics. Okay, so finally we're using this vocabulary word, this T statistic, right? We're gonna use this T statistic, right? In the last unit, we called it Z statistic. Here it's T statistic. And we're going to use it to find our p-value, right? So in order we can state the hypothesis. Compute to compare, so this is where we do all our computations. Oh, and for prepare, we have to check for just two conditions. So we'll go over that. Compute to compare, and then lastly, interpret, right? So let's do an example problem. In 2008, 2009, the mean cost of all two-year colleges was 2,517. For 35 two-year colleges during the 2012-2013 academic year, the mean cost and standard deviation were 2,919 and 1,079. All right, test a hypothesis that the mean tuition cost at a two-year colleges has increased. So for the 2009, sorry guys, since the 2009 2010 academic year. So we suspect that it has. We checked 35 schools. We got their mean and their standard deviation. We have all the information we need to do this. So, sorry. Step one, come up with a hypothesis. So our null hypothesis is that it stayed the same, and our alternative hypothesis is that it increased. So remember, guys, right, because we didn't use this means two-tailed, right? This is us reaching back to the last unit, right? And if we use this or this, it's one-tailed. And remember, when we talk about tail, what we're talking about is where we're shading in our normal curve, right? Two-tail means when we say not, we're going to go both sides. One tail could either be above or below, right? But it's only one tail of the curve. All right, so here's our hypothesis. So when I check your work starting tomorrow, I'm looking for equal signs for the null hypothesis and not something without an equal for the alternative hypothesis. Okay, condition one. Um, so now we're in step two, prepare. Condition one, it's random. It even said so right here, right? It said that the mean cost for two. Oh, okay, so I could say it was random. I guess I just forgot to write it down. Large sample, remember that magic number is 25. So if the sample size is bigger than 25, condition two is met. If it's not bigger than 25, and they don't tell you that it's normally distributed, then you're done. You say you can't go past step two, okay? So remember, 25 is a big deal. All right, 5% significance level. So remember, whatever our p-value is, we're gonna check it to 0.05. If it's less than that, then we're good. If it's greater than that, then we can't, the data doesn't determine that we can reject the null hypothesis. All right, compute to compare. So first things first, right? Don't forget, the standard error is taking the standard deviation, right? And dividing it by the square root of the sample size. So this is our standard error. Now, what we're going to do is we're going to compare the mean minus the null hypothesis, right? So we're going to minus the mean of the sample minus the mean from the null hypothesis. And then we're going to divide that by our standard error to get the T statistic. Now what you're going to do is you're going to go to your calculator. That's what I get for, I had this all prepared before and then life happened. All right, so not a big deal. So you go to T statistic hypothesis testing calculator, single sample T statistic, and I will put the this, I like the site, and I'll just put that in our for in our in the in the assignment for you. All right, so let's just go to the calculator. You can tell that it's close to the end of the year because I'm not going to stop my recording. I just got to finish this. All right. Okay, so the population mean. Oh, this is. All right, we're going to go to this one instead because Mr. Pilcher is just not having this right now. Thank God. Here we go. So here's our t-score. Sorry, the other one you had to put in all the values, and I just was not putting in values. So here's the t-score. So we calculated the t-score to be 2.2. So I'm going to type in 2.2. Oh my goodness. All right, 2. And DF is your degree of freedom, which, by the way, all you do is you take your sample size and you minus 1. So 35 minus 1 is 34. So we have 34 is our degree of freedom. We want a significance level of 0.05. And remember, I told you guys, right? Two-tailed is when it's not equal to, but they didn't say that. They said greater than, so it's one-tailed. And that's all you have to remember, is it one-tailed or two-tailed, right? So the p-value is 0.01, which is less than 0.05. So I can copy and paste this into for both step 3 and step 4, right? Because this is telling me since p is less than 0.05, I can, here, let's go to that slide. P-value is smaller than 0.05, so we conclude that the data suggests that the mean tuition cost is higher in 2013 than it was in 2009, 2010. So I'm going to walk you through this again tomorrow and on Friday. We're actually going to end the unit with this because our big project is going to be rolled out on Monday. And then that's it, guys. Next week is the last week of anything new, and we're just doing the big project. All right, so great job so far, and just fill out your guided note.